Hello my friends, in my last video lecture, so I have covered many properties. That means I have covered actually these properties del of minus t is equal to minus del t, integration minus infinity to infinity del dash t dt is equal to 0, xt del dash t is equal to x of 0 del dash t minus x dash 0 del t. In this way I have covered actually many properties in my last part 1 and part 2 of doublet function. Okay, now see नेक्स्ट प्रॉपर्टीज पढ़ते हैं आज के क्लास में। नेक्स्ट प्रॉपर्टीज पढ़ते हैं, क्या क्या प्रॉपर्टीज है नेक्स्ट और क्या क्या प्रॉपर्टी बचा हुआ है देख लेते हैं। देखो ये जो लास्ट वाला प्रॉपर्टी है डेल डैश एटी इज इक्वल टू 1 बाई ए मॉड ए डेल डैश टी, दैट मीन्स दिस प्रॉपर्टी इज नोन एज स्केलिंग प्रॉपर्टी ऑफ डबलेट फंक्शन। स्केलिंग प्रॉपर्टी ऑफ डबलेट फंक्शन, दैट मीन्स डेल डैश एटी ए इज ए कांस्टेंट, सो यू कैन टेक आउटसाइड इन दिस मैनर 1 बाई ए इंटू मॉड ए डेल डैश टी। नाउ इन प्लेस ऑफ दिस एटी सपोज आई विल कंसिडर डेल डैश a plus b, another constant I am introducing, then what will be its result? So this is one of the most important property you can say in case of your doublet function. So now let me discuss this property. Okay, so see what you have to do. So you know in case of impulse properties also I have covered so many properties of impulse. Okay, one of the most important property of impulse, that is not actual doublet, impulse. Let me consider first impulse. Impulse is what? Del at plus b. So now what is this property? It tells 1 by mod a. So see first you can write in this manner, del a you can take outside, t plus b by a, within the bracket you can put, now that is 1 by mod a del of t plus b by a. So this is the property, that means del a t plus b is equal to 1 by mod a del t plus b by a. So this is the property which in case of your impulse. Now if in place of impulse you are putting doublet function or doublet signal, that means what? Del dash at plus b. See here it is del at plus b, that is known to you, 1 by mod a del t plus b by a. But in case of del dash at plus b, what will be the result? What will be the result? Okay, see, so the result will be in this manner, 1 by a mod a, nothing is there. Here it is 1 by mod a, here it is 1 by a mod a del of t plus b by a. That's all. Del, not del, del dash of, because you are considering doublet function, del dash of t plus b by a. So this is very very important, try to understand. So this happens in case of your doublet function. Now let us prove this property. It is very simple, you know this. So see del, proof देखो, proof बहुत आसान प्रूफ है, डेल ऑफ ए टी प्लस बी दैट इज इक्वल टू 1 बाई मॉड ए डेल ऑफ टी प्लस बी बाई ए. सी हियर इट इज वेरी सिंपल, टी प्लस बी बाई ए. नाउ इफ यू टेक डेरिवेटिव विथ रेस्पेक्ट टू टाइम ऑन बोथ साइड्स, you just take derivative with respect to time on both sides. Understood? So what you will find? What you will find? So if you take derivative here, this will becomes del dash at t plus b, then derivative of this inner term, derivative of inner term is a, because at t plus b, if you differentiate at t you will find a, if you differentiate b, that is a constant, you will find 0. Understood or not? So now that means if you differentiate, what you will find? A del dash at t plus b. Okay, now see, if you differentiate this 1 by mod a is a constant, so this is your del dash t plus b by a. If you differentiate the inner term, again you will find 1, because b by a is a constant. So now see, del dash a t plus b, this a you just take this side, 1 by a mod a del dash t plus b by a. देखो प्रूव हो गया, प्रूव हो गया, बहुत आसान प्रूव है. That means whenever you are observing del dash at t plus b, this is nothing but 1 by a mod a del dash t plus b by a, del dash t plus b by a. But whenever you are observing in case of impulse del at t plus b, this is equal to 1 by mod a del t plus b by a. So same thing you can write for minus, that means del dash at t minus b. So similarly del dash at t minus b, nothing is there, that is equal to 1 by a mod a del of t minus b by a. Simple, very simple. This is del dash t minus b by a. Understood? So this property is very important property, and it having the application whenever you will solve questions. Understood? Okay. So this is one of the important property in case of your doublet function. Now next property पढ़ते हैं. Next property क्या है? देखो, next property actually suppose you are having the integration of any function xt, integration minus infinity to infinity, suppose xt del dash t then dt. See, what will be the result? Integration minus infinity to infinity xt del dash t dt. What will be the result? It is very simple. The result is nothing but you can say minus of x dash 0. So this is also another important property, very important property in case of a doublet function. Just like integration minus infinity to infinity xt then del t then dt. So that is your x of 0, simple. That is your x of 0. But here it is minus x dash of 0. Then how to prove this? Very simple. So you know, in case of let us prove this property. देखो prove कैसा किया जाएगा. Integration minus infinity to infinity x of t, this is del dash t, this is your dt. Right, understand? Suppose this is your LHS. Okay, this is your, suppose नहीं, this is LHS. देखो, now xt del dash t dt, use integration by parts. First function integration of second minus, देखो, that is equal to first function क्या है xt. Integration of second means you have to integrate del dash t. Integration of this del t minus integration derivative of first function means x dash t. Integration of second function means del t then dt. समझ में आ गया? बहुत आसान है. Now overall limit you have to put minus infinity infinity. Now see here. First here you just put the limit xt del t, limit minus infinity to infinity, minus integration minus infinity to infinity xt del t dt. Clear? Sorry, x dash t del t dt. Now if you put actually here, see, nothing is there. You know xt del t, this is x of 0 del t, this is x of 0 del t, x of 0 del t. Then limit you have to put minus infinity to infinity, minus integration minus infinity to infinity. See here, x dash t del t, product property of impulse, x dash 0 del t, this is x dash 0 del t, then this is your dt. Try to understand. Okay, so now what you will find, this is equal to x of 0 is a constant. If you put first infinity, del of infinity is what? 0. Del of infinity is what? 0. Minus x of 0, del of minus infinity is what? Again 0. That means x of 0 del of infinity into 0 minus x of 0 the constant, del of minus infinity again 0 minus, see here, x dash 0 you can take outside, integration minus infinity to infinity del t dt. See here, now this value is what? 1. Area under impulse, unit impulse is 1. So that means this value comes 0 minus x dash 0, because this is 1 into 1. That means you will find finally x dash 0. Understood? So this result you will find x dash 0, that means this is your RHS. First you have taken LHS and you have find out the result, which is nothing but your RHS. That means LHS is equal to RHS proved. So therefore xt del dash t dt is equal to minus x dash 0. Understood? This is also another important property in case of your doublet function. Understood? Now देखो, एक काम करते हैं, अगर इसमें मैं शिफ्टिंग लगा देता हूं, that means integration minus infinity to infinity x of t del dash t minus t0 dt. Nothing is there, same result, that is nothing but minus x dash t0. Because if t minus 0 means t, then you are getting minus x dash 0. T minus t0, that means minus x dash t0. Similarly, integration minus infinity to infinity xt del dash t plus t0 dt. What result you will find? Minus x dash minus t0. Because here this plus t0 you can write minus t0. Understood? So this is also another property which is the property of a doublet function. Understood? So many properties I have discussed in case of your doublet function. Next, we will see other things related to doublet functions. That may be other property, another important property is also there. In my next discussion, I will discuss that property, which is the most important property of the doublet function. Okay. Till then, thank you.